Hello, my name is Kez. Today I'm going to talk about structured problem solving. So what is structured problem solving? Really, it's just a way of approaching technical interview questions or any technical software problem in a way that's not random. Instead of, just writing down a bunch of code, you think about it and you approach it in a systematic way. So when can you use structured problem solving? A few examples are when you're faced with a problem that has several layers. So maybe you need to iterate through a string. You also need to separate it into a list of strings. You need to convert it to lowercase and so forth. When there are lots of different layers, it's easy to get lost in implementation unless you think it through ahead of time and sort of plan what you're going to do incrementally. Another situation is if you're given a problem where different cases needed to be handled differently. When you're thinking about this problem, it's common to accidentally forget about certain cases and plan for the expected case. Then when you hit those edge cases, your program might not behave the way you expect it to. The final example is when the solution is not immediately solvable for you, or you've only been able to come up with the brute force solution, so you want a way to think about the problem that will take you to that next, more optimized step. So why should you use structured problem solving? Well, it helps avoid that code first, debug later pitfall that so many new developers fall into, where they start writing code and by the time they're finished, they don't realize how many bugs they've put into their code. And as they start to debug, it takes way more time than it would have taken to just rewrite the solution in a more structured way. It also helps with planning for unexpected and edge cases and thinking about them intentionally. It can lead to a more optimized solution. It can also give you a reliable system that you can sort of lean on in an interview when your nerves might otherwise interfere with your ability to think clearly. This also gives you a bit of a script that you can follow in an interview to explain your approach to the interviewer and create an interactive dialogue. So let's go through an example of what structured problem solving might look like for a specific problem. This is most common word from leetcode.com. Go ahead and pause the video, read through the problem statement, the input, the output, and the explanation. All right, so you can see that this might be categorized as a layered problem where there are lots of small things that we need to take care of here that might be a little difficult to keep track of if we just started writing code. So let's consider how we might solve this using structured problem solving. How would you approach this? Go ahead and pause the video and think about some considerations that could come into play with this problem. All right, so here's a list of things that I came up with that might help approach this problem. First, I would list any special cases using the constraints that were listed in the problem statement. Then I would make a list of subproblems, the small things that I know I'm going to need to do for a solution that I could implement in many different ways. Then I'm going to start finding those individual ways that I could implement it. What tools can I use to solve the subproblems? And in what order? Can I do some things together? Do they all need to be separated? How can I combine these tools together to create an optimal solution? Once I've thought all that through, I'll start sketching out a solution, seeing where I can place things and create a sort of outline or design for my solution. Once I'm happy with that design, then I would start implementing. So what are the special cases for most common word? Well, when we look at the constraints that were listed, it becomes clear that there are three edges where we might see unpredictable behavior if we don't account for them. So we'll keep these in mind as we design a solution. What are some subproblems that we can identify within this problem statement? Go ahead and pause the video and see if you can identify them. All right, well, let's see what I came up with. The subproblems I identified were identifying individual words within paragraph, ignoring punctuation, converting paragraph letters to lowercase to compare them to banned words. Associating each word to its occurrence count in paragraph. Ignoring banned words. And determining which is the most common word. Now, when we return the most common word, we must remember that it has to be returned in lowercase as explained in the problem statement. So when we identify tools to solve these subproblems, we need to look at the specific language that we're using and the tools that exist within that language. When I looked at this problem, I was looking at it through the lens of C++, and these are the tools that I came up with that might solve this problem when organized together. Now here is one example of a way that we could design a solution and then get ready to implement it. Go ahead and pause the video and look through this. See if you understand the solution. As you can see, there are a few different steps here. First, we declare a few variables that we know that we're going to be using throughout. Then we iterate through each individual character in paragraph. When it's a character that is a letter, we add it to the word, the current word that we're evaluating. If it's not a letter, we just move on. We ignore that character. Once we have put together all of the letters for the current word that we are evaluating, we're going to add that word to a map of words and increment the number of occurrences that exist for that word in paragraph. Then we're going to clear our word and we're going to go back to the next character and see if it's a letter or if it's not a letter. Then we'll have a map full of words and the number of occurrences they have in paragraph. We'll then go through each banned word and set the occurrences of that word to 0. That way it won't be considered when we're looking for the most common word. At that point, we search the map for the word that has the maximum number of occurrences, and we return that word. Now, if we're going to oversimplify, we can call this time complexity O of n, but really it's O of n on the number of characters in paragraph, and then you would add that to, say, an O of m, which is the number of banned words in the list of banned words. Now, of course, this is implementation dependent. So for example, if you were using a standard map in C++, this would not be O of n. But if you're using an unordered map, it would be. So now for an exercise. We've stepped through most common word together. So see if you can go through this problem on your own. Go ahead and pause the video, read through the problem statement, the input and the output, and see if you can figure out how to approach this problem. All right, so let's look again at a few ways that we could evaluate this problem. We can look at special cases, we can look at subproblems, the tools for those subproblems, and create a solution design. Now, if you want to check the results that you got when you tried this exercise, there will be resources at the end of this presentation where you can see what I came up with and see how they compare. Of course, I'm always looking for feedback, so if you came up with something very different from mine that works, let's talk about it. Here are some resources if you're curious about moving a little further with these problems. For most common word and for implement string, we've got the LeetCode problem as well as the STEPIC lesson. Now these lessons are lessons written by a research group at UW-Bothell, and they are designed to not just give solutions to LeetCode problems, but to explain the solutions and offer many different solutions to give you a bit of context and understanding. So please feel free to check those out. At those lessons, you will see how I decompose the problems and solutions that I came up with. Additionally, there's a video, a capstone presentation on structured problem solving that I presented during my colloquium. You're more than welcome to check that out. It talks a little bit about my research into this subject. Thank you so much for listening. Please leave me a comment if you have any feedback. I'm very curious to see what you think.